Okay, so the second example here that we have is I'm going to look at a different way of sketching this one. This is very similar to the very first one that we did a couple days ago. This method will work for all rational functions that just have a degree of 1. So you see this is just an x. If there's an x squared, it becomes a little bit more challenging. But what we're going to do is just consider a completely different method in solving these. Now, I don't expect you to memorize this or anything like this, but I expect you to understand where this comes from. Okay, so just watch and enjoy, and if you want to make notes on it, you can, but that's up to you. So the first thing is we have to remember what rational functions are. They're a polynomial being divided by a polynomial. That symbol means divide. So why don't we actually do the division? We have to do it when we're looking at oblique asymptotes and stuff. So let's actually do the division. So this is x or 2 plus x, otherwise known as x plus 2. So I'm going to divide that. So it's x plus 2, and it's divided by x minus 4. So let's do the long division. It'll seem really easy. We ask ourselves, what do you multiply by x to get x? Well, it's just 1. So it's rainbow. So it's 1 times x is x. 1 times negative 4 is negative 4. Subtract. So it's 2 minus minus 4, which is the same as plus. And I get a remainder of 6. Okay. So if I considered this, let's write the division statement for this. This is x plus 2 now. It can be expressed as 1 times x minus 4. Remember, multiply the quotient and the divisor, plus a remainder of 6. This is the division statement. Okay. Now watch this little another step. I'm going to divide everything by x minus 4. So I'm going to divide by x minus 4. And the reason I do that is because I want this to be like my function. Well, look what happens when I divide everything by x minus 4. Of course, this is just x plus 2 over x minus 4, which is the function I want to sketch. When I divide this, of course, this would cancel. I'm left with 1 plus 6 over x minus 4. That may not seem like anything, but this, I'm just going to call this f at x now because I'm left with, this is the same function that I'm dealing with. I'm going to write it like this, 6 over x minus 4 plus 1. Write it like that. Well, you know what? I could have asked you this test on our very first test of the year, this question on the very first test of the year. Try and sketch this. First thing you'd have to do is identify the function. Well, notice this is 1 over x with a whole bunch of stuff done to it. The minus 4 is inside the function, but it's moved right 4. Remember, it's inside the function, so it's opposite to what you think. So this is the 1 over 4 function moved right 4. The 6 is outside the function. This is a stretch of 6. And what does this plus 1 mean? Well, it's outside the function, so it's just moved up 1. So then, if I wanted to sketch this, let's just get a graph out here. So if I wanted to sketch this, I'm just going to think of the original function. Okay, that original function has an asymptote down here, an asymptote here, and it looks something like this, right? That's really light, so I'm just going to draw that with my pencil. Let's draw that really light. And that whole function then has to move to the right 4 and up 1, and then it's stretched. Okay, so if the rational function, the original one, moves right 4, that means that the asymptote must move right 4. So that means the new asymptote's right here. The horizontal asymptote moves right as well, but it also moves up 1. So it moves to there. And then this entire thing is just stretch 6, which just means sort of curves further away. So it goes something like this. You could go off and find some intercepts and get a pretty quick way to draw that graph. Of course, it's not quite as easy when we have, you know, the other functions that have got cubics and quadratics and stuff in it, because we don't have a base function to start with. But if it just has an x in it, you could use this method, divide, get a division statement, and rearrange your whole question into something where you could just take the original 1 over x function and move it using the translations that we studied at the beginning of this year and in grade 11. So that's just an interesting thing, something to make you go, but that's all we're going to do today. So the rest of the day, I'd like you to practice your sketching. I've left the answers with that worksheet with the supply teacher, so you could take those and double check the ones you've been practicing. And this will be the 3rd day that you'll be practicing these sketches. We'll have a couple of more days of just some small lessons, and then remember our test will be next week. Thanks. See you tomorrow.